Hi guys, welcome back to my channel. So in this video I'm going to go over calculus 2 topic, which is partial differentiation, and in this video I'm going to go over improper fraction. There are a lot of cases for the partial fraction, but I'm going to go over improper one. So how do I know, first of all, that this is an improper fraction? So to determine that, there's a rule which says if the degree of the numerator is greater than equal to the degree of the denominator, that means it's an improper fraction. Okay, so let's see if that's the case over here. So the degree means simply the highest exponent. So the highest exponent in here is 3, right? Okay, so the highest exponent in here is 3. And what's the highest exponent in here? It's 1, because it's x to the power of 1, right? Okay, so highest one is at the numerator, right? Which is the top. So if the, like I said before, if the degree of numerator is greater than equal to the degree of denominator, that means it's an improper fraction, which is the case over here. Okay, so now since it's an improper fraction, we know that we have to convert it into a proper fraction to be able to solve for partial fraction. Okay, so to convert it into a proper fraction, we have to do the long division. Okay, you guys remember the long division? You guys probably learned that in Sec 4. I know it's a while ago, so let me recall how to do this. I will do it step by step, so you guys will recall, don't worry. Okay, so this is the denominator. Denominator is always the bottom part, right? And the numerator is the top part. Okay, so the denominator always goes outside this thing. Okay, so the denominator goes outside, and well, the numerator, what's at the top, goes inside. Okay, so now we are about to do the long division. Okay, so we have to divide this by this. So first of all, you see x to the power of cube, and you have x over here. So what do you have to do so that you get multiply x? What do you have to multiply x with so that you get x cubed? Right? You have x over here, you want to get x cubed. So what do you have to multiply? You simply have to multiply by x squared. Because why? Because when we multiply, we add the exponent, right? X and x. You're going to add them, so it's going to be x cubed. Okay, so we have found we have to multiply with x squared. Alright, so multiplying with x squared gives us x cubed. That's what we were looking for, to be able to cancel it out. And now we're not done yet, because you see a -1 over here, so you have to multiply the x squared with -1 as well. So -1 times x squared, that's negative x squared. Now you have to subtract the whole thing. And important, when you're subtracting, you remember you have to multiply multiply these with the brackets as well, like within the brackets as well. So the sign is going to change. So I'm just going to use a different color so you guys don't confuse. So when you're going to multiply, so that's going to become negative, and then negative and negative, so that's going to become a positive, right? Alright, so now we can continue with the problem. Let me remove this so that you guys don't confuse. Okay. Alright, so we cancel this out because there's negative, positive, so we cancel it out, and we cannot cancel the x with x squared, right? You cannot also add them because they do not have the same exponent. So what you're going to do, you're going to bring this down just like as it is, and then you're going to bring this down. Alright, so now let's continue the problem. So now we need to get x squared, and we have x. So I guess now you guys know what you need to multiply with to get x squared, right? You have x, and you're looking for x squared, so you have to multiply x with a positive x, right? X times x gives x squared. Okay, now you have to multiply with this -1, so -1 times x, that's negative x. And then subtracting this whole thing, changing the signs again. So negative and negative, that's gonna become, negative times a positive, so that's gonna be a negative, and then negative, negative, this is going to turn into positive. Alright, so then going to subtract it. So this gone, and this is a positive, right? So positive, positive, that's going to be a 2x. Okay, so now we have 2x and we have x over here. So we have x. What do we multiply this x with so that we get 2x? We have to multiply with a 2, right? Yes, so 2 times a x, that's going to give us 2x. That's it. And now we have a negative 1 over here. Of course, negative 1 times 2, that's going to be negative 2. Okay, and subtracting again, so negative, we have to multiply this negative with this one, so negative times positive 2x, this is going to become negative 2x, and then negative times negative, that's going to become a positive 2. Alright, so we can cancel this out and we're left with a positive 2 over here. So now we have a 2. Can we get multiply this x with something so that we get a 2? No, that's not possible, because whatever you multiply with you're still gonna get an x, right? But we don't need an x, so we are done with this problem. That means we can no longer solve it. So this is the remainder. So that means our proper fraction can be written as like this. Okay, so this is what goes at the outside of the division, right? So this has to go at the bottom, like I said before, right? So let me show you here. It was at the bottom, so that's why it was outside the division. So that's why I'm writing it at the bottom. Okay, and our remainder goes at the top. So what is our remainder? Our remainder is 2, so that's gonna go at the top. My 2 looks so weird. Okay, now it's better. Okay, and what we have here at the top, it's just gonna go in here. X squared plus x plus 2. Okay, so this is our proper fraction. So we're not done with the question yet. We have just converted the improper fraction into a proper fraction, but we still have to solve the problem for the partial differentiation. Okay, so let's do that now. We are integrating this, right? So we need to write it like this. Integral of x squared plus x plus 2, and then plus 2 over x minus 1. Let me just separate this so you guys don't confuse that it's the same thing. And yeah, by the way, you don't need to write the notes. I'm gonna provide the link to the notes in the description below, so you can just click to that link and then get the notes. Don't need to write them out. Alright, so we're differentiating this problem, and you know, when you're differentiating, this is the integral, right? So you can break them into parts. So this is, you can break it into smaller parts so that it makes your life a little easier. Okay, 2 dx plus 2 over x minus 1 dx. So you can differentiate what you can right now. So I can differentiate this, so that's simply x cubed over cube, plus this is simply x, so that's x squared over squared, plus what's the integral of 2? Integral of 2, it's 2x, since it's a constant, and then here we have this thing over here, and we need to do some work to find the integral of this one. Since there is since it's written as a fraction, so you need to use u substitution. Okay, u sub. So let me do the u substitution here. Let's make a separate space. Okay, so I can do the u substitution over here. So what's at the bottom is our u equals to x minus 1, and then du. What's our du then? du is simply the derivative. We can write this problem in terms of u then. So this is our initial problem, and we need to write it in terms of u.
Okay, so we're replacing this with u, right? U. And then dx, we need to convert this dx into du as well. So here dx is simply du, no need to do algebraic manipulation. If it was something else, like du equals to, for example, 1 divided by x, then you have to do some algebraic manipulation to find what is dx. In this case, we don't need it because we write 1 or not, it doesn't matter. So in this case, du is equals to dx, so you can simply replace the dx with du. Now, you can, once everything has u and du, now you can integrate it. So u over, or if you want, you can factor the constant out. So we have a constant over here, 2, so we can factor that out, and then we're left with 1 over u. 1 over u du. And I think you know what's the integral of 1 over u. And yeah, you are right. That's ln of u, absolute value of u plus c. And now you can, once you have done the integration, you can substitute back the u. So what was over u? So over u was x minus 1. So I'm going to replace it in here. X minus 1 plus c. So here, we have solved this problem, this mini problem that we were dealing with. So we can now solve our big problem that we had over here. So we have the integration of this one that we just solved over here, which is 2 ln of absolute value of x minus 1 plus c. So we can write it over here. 2 ln of x minus 1 plus c, and that completes our problem of the improper partial fraction that we had. I hope you find this video helpful, and thanks for watching. Bye!